and welcome. How's everyone's Jenkins world going? Good, okay, that's enthusiastic, I like it. So this is Microsoft Linux open source, DevOps, and cloud, obviously. My name is Jessica Dean. I work for Microsoft. I'm a cloud developer advocate. And I'm here today because I love technology and community, which means I have the best job in the world because I get to code, play with technology, and talk to people about code and technology. I focus heavily on Linux, open source, DevOps, and cloud or containers in the cloud. Non-technical things about me, I love Disney and CrossFit fitness, so if you do follow me online, you may or may not see some of my geekery. I also love shoes, so I'm wearing my Jordans today. And I found that a lot of people at this conference also love shoes. I've gotten so many compliments on these. You can follow me online at JL Dean, no relation to James Dean, so there's 2 E's in my name, on GitHub, Twitter, and Instagram. Quick disclaimer before we dive in and get started. The next 45, technically 44 minutes, because we spent a few taking a selfie, is not intended to make you an expert. But this content is designed to get you thinking, to show you what's possible, also educate you on Microsoft's open source story, and then finally, give you some sample code and open source tools for you to use and get started on your own time. Now let's talk about technology and where we're at in the state of our industry. Some might say we are going digital, or we're in a transformation era. This was a study that was done by both Business Journal and Gartner, and it was estimated that by 2020, 1 million devices per hour would be coming online. 1 million devices per hour. 2020 is less than a year and a half away. The average age of an S&P 500 corporation by that same year is estimated to be 12 years of age. Compare that to the 1960s, where the average age was 60 years old. Companies are getting younger, we're having more and more devices come online. How do we kind of deal with this transformation, with this digital era? The last statistic, I think, is actually a little underestimated, but it was stated that 60% of computing would be performed in the public cloud by 2025. It's 2018, it's less than 7 years away. And I think because we already have such a shift to the cloud, that percentage is a little low. It's probably closer to 70, maybe a little higher. So when we deal with this transformation and this digital state of our industry, how do we deal with the momentum? First, we have to listen to our people. So we have to listen to developers. And by the way, for any IT or ops in the room, you'll have your moment too, okay? That's my background. We also get to shine and gripe a little. But from developers, here's things that we hear. Maybe this sounds familiar. I want to be able to move fast. I want to be able to iterate. I don't need IT or operations being my bottleneck. Things run smoothly on my dev system, but I hand it over to IT and everything breaks. It's your fault. So as a result, my productivity and my ability to innovate become suspended because I have to wait on IT. And again, I promised you IT, we get our moment. Here's what we hear from IT. I need to minimize risk. I need to worry about compliance. I need to make sure that I stay within my corporate compliance policy. I'm unfamiliar with the applications that you as developers might give me. I need to work with you so I can make sure everything's streamlined and working well. I can't focus on both infrastructure stuff and handle the application operations and security simultaneously on my own. I have to work with you. So if we look at both pain points from both the dev perspective and ops perspective, here are common stress points we have. And I label this IT stress points, but it's not just IT for the IT pro person. It's if you work in information technology, if you touch software, if you write software, if you handle the architecture that software runs on. These are our stress points. We have to focus on security, we have to worry about efficiency, and we have to support this innovation and this transformation we just identified. That's where it kind of comes into this new era of computing, right? In the 1970s, the mainframe era, you probably had one computer for several users. Fast forward a few decades, the mobility era, you now have several computers per user. And then fast forward a few more years, now it's several computers and devices per user. But 2020 that we're talking about and thinking forward thinking, that's going to be the ubiquity era. We now have thousands of computers, or potentially containers, little encapsulated environments per user. I think at my house alone, I probably have 10 computers. And then who knows, iPads, iPhones, everyone else's. We're in this rapid growing era right now. So that's why cloud is so talked about. That's why that statistic I estimated is a little low, but that's why anybody thinks that over half of computing will end up being done in the cloud in less than 7 years. Because cloud is the new way to think about a data center. Your traditional model, you had dedicated infrastructure and architecture for each application. The hardware you had was purpose-built for that project. Your distinct infrastructure and operations teams were often separated. The way that I usually give an example is it's like a 6th grade dance. You have people on one side of the room, people on the other side of the room. No one wants to come to the middle and have fun and dance. And the processes and configurations you had were customized for each project, for each application. That's super helpful. You guys can't see it. Let's restart this. While I'm just plugging and replugging it back in, I'll finish. The cloud model really kind of sets up new innovation, new ability to kind of think about our data center, right? We have loosely coupled apps and now microservices. The hardware we have is industry standard, as opposed to just purpose-built for this one project, this one piece of hardware that we procured. Our teams that we have that focus on delivering a service are DevOps-focused teams. We now have this union and this collaboration. And the processes and configurations we use to achieve these deployments and ultimate delivery of software are standardized practices and processes. That's why DevOps is really kind of central to this entire story, whether it's open source, whether it's Linux, whether it's Microsoft, anything with technology, DevOps is central. It starts with people, as we've identified. Then we have to identify the process. And then we start talking about the products. And today I'll show you quite a few open source products that Microsoft is either contributing to or directly in ownership and working with the open source community that we can use to achieve success and deal with this transformation. So what is DevOps? DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word in that definition is value. If you're not delivering value, what are you doing? Are you able to know if you're delivering value? Do you have telemetry? Do you have metrics? Do you have logging? Do you have insight into what your end users are using with whatever the tool is? Are you delivering value? Key practices that you'll hear in DevOps and that you'll end up hearing in some of the tools we'll talk about today. Infrastructure as code. You might also hear pipeline as code. Automated testing, availability, monitoring, continuous integration, continuous deployment, release management, performance monitoring, the ability to roll back and roll forward in an automated fashion, load testing, autoscale. All of these are standard practices, and they start tying in to several products, several tools that we'll talk about. Benefits of implementing DevOps. And of course, these numbers, while they look maybe a little shocking due to change over year, remember they're relative. But ultimately, you're able to deploy code significantly more frequently. Your lead time for changes increases. Your mean time to recover in the event of a failure increases. And your change failure rate, the likeliness you're going to fail, decreases year over year. And this is a study that's done every year by Puppet Labs. The DevOps report actually just came out, I think, about 2 weeks ago for 2018. So now we've talked about DevOps, we've talked about practices. We kind of understand there's a transformation going on. How does this tie into the other shocking words in the title, Microsoft Linux open source? First, let's get the elephant out of the room. This is a news article from 2001. For anybody in the audience who might have an 18-year-old kid, Your kid was 1 when this was published, so it is 17 years ago. And every slide I've been talking about for the last 9 minutes or so, we've been talking about the future. We've been talking about where we are. We're trying to do forward thinking. This is irrelevant because this is today. And this has been the current Microsoft for the past 4.5 years. A lot of people don't know, but internally in Microsoft, as of 2014, our CEO, Satya Nadella, directed all Microsoft engineers to open source internally. Anyone at our company can see anyone else's code and use it as needed. So I can go take a look at the Windows code, or the Kubernetes code, or the Helm code. But by the way, even though we own Helm and it's an open source project, you can also go take a look at the Helm code, because it's publicly available on GitHub. But this vision that Satya had in 2014 is my everyday reality. Every single demo I do is online and open source. It's just a way of thinking. So now we've talked about philosophy, we've talked about DevOps practices. We're going to start tying this back to the cloud and start tying this back into DevOps in action. So here's where we get to have some fun and not look at slides, as colorful as my slides are. I'm going to exit out of this, and we're going to go over to a live demo as soon as the delay fixes itself. So if you follow me on social media, again, you may have seen Croc Hunter before. It's a little well-known game also in the open source community. It's technically like a JavaScript application wrapped in Go. It's pretty epic. It was written by Lockie Evanson, who's on our Helm team. And I can shoot crocodiles and live out my dreams of hunting crocodiles by shooting fish, which is, I mean, cool. But this is Jenkins world, and it's just not cool enough. So how about we spice it up? I'm going to switch over into VS Code, which is also open source and cross-platform and owned by Microsoft. And I'm going to make a little game change. While I do, I'm going to go ahead and push it to my GitHub repo. And before anyone asks, there's a slide at the very end that has links to everything I'm demoing. It's a markdown file. You can have links until your heart's content. So I'm going to go ahead and type in game-jenkins. It matches a game-jenkins JavaScript file I have right here. I'm going to zoom out. I'm going to save, go over to code, add that in, hit demo change, commit, and push. Now that's going to make a live change right now while I'm on stage. While that makes that change, I'm going to flip over to this screen here. We'll go over to my Jenkins instance. And yes, I do have my Jenkins build server that's going to handle this deployment for Croc Hunter. And as soon as that pushes out, we should see, there we go, it's triggering off. So this is going to take a little bit while it queues and it waits for the executor. But this is Jenkins that's running on a Kubernetes cluster in Azure Cloud. Kubernetes is an open source container orchestrator. If I switch over to my dot files, which are also open source and on GitHub, you notice that right now there is a second pod that just fired up that says container creating. That's my job that's firing up to handle my Croc Hunter deployment. So it's going to go out and it's going to make everything so much cooler as it runs through the pipeline. But rather than sitting here and just watch it go through compile and test deployment and all of everything, let's switch back over to code, and we'll take a look at what's actually happening. So we talked about infrastructure as code, the ability to stand up your infrastructure, and everything's just in code, and then also your pipeline as code. This entire repo that you'll have access to has everything. It has the infrastructure, and it has the pipeline. So my pipeline that I'm running for my Jenkins file is literally a Jenkins file that you can see up at the very top. I have a library that I'm importing. I'm defining my pipeline. I'm defining a pod template. I start scrolling down. I check out my code. I scroll down more. I'm having it run any kubectl commands. I'm having it compile and test and use Golang. Everything's in code. If I switch over to my ability to stand up infrastructure, I can switch to my Jenkins file. I actually deployed out my entire Jenkins server with plugins, with everything predefined, in less than 5 minutes using this file. And we're going to see a live demo of that at the very end. And this uses Helm charts. So Croc Hunter is also designed for Helm, which is the package manager for Kubernetes. By the way, every single thing I'm showing you is open source. Kubernetes is an open source container runtime. Helm is an open source tool. Helm is a package manager for Kubernetes. So I use what's called a values file, just like what you saw with Jenkins, and I define out everything that I need for my deployment, the service type, the component, how many replicas I need, where it needs to get the image, if there's pull secrets because it's a private repository. I define everything in one file so that even if I have an incredibly complex deployment with services, deployments, ingresses, databases, CI, you name it, it's everything in one chart. It does that because when you look at the templates and zoom in here, it's essentially just parameterizing it. It's a declarative variable pipeline. But it streamlines everything and keeps it a lot more simple. So if I zoom out, and we'll go back over to Jenkins and see how well it's running. It's publishing my container right now, should finish shortly and deploy. After this pipeline finishes, we'll see how everything is encapsulated to the point to where if you were to take this, fork my repository, make a few minor changes for your own images, your own whatever, you could have this same demo up and running in less than 30 minutes, in less time than it will take me to give this entire talk. So it's deploying out, and I want you to see my awesome version of Croc Hunter. Like I said, I wrote it just for you guys. I'm so proud of it. It's running through a few more. Let me see if there's anything else while it's going through on the deployment. One thing you can also do in Helm charts is you can also add in web tests. So I also even have web tests that I've defined as part of my deployment. So it's going to double check to make sure that the test is up and running, and only then is that pipeline green. And you can have that test even apply to pull requests, different branches, feature requests, and so on and so forth. That's one more thing that's pretty cool. You can see, actually, conveniently enough, it is running the Helm test right now, which it just succeeded. So everything should be green. We'll flip back over to Croc Hunter. Ready for the Jenkins edition? Go ahead and refresh. Jenkins edition, hit start. Guess what I get to use to kill these crocodiles? Butlers! Yay! All right, thanks for letting me humor you. Like I said, I was so excited. All right, so now we're going to switch back over. Have to look at a few more PowerPoint slides. So what just happened, aside from we got to use butlers and it was awesome? First, I have code in GitHub. Then I have Jenkins set up in a Kubernetes cluster that's also set up to handle my Kubernetes pipeline. It's handling my Docker build. It's handling my Helm package. And it's deploying out to Kubernetes on Azure using AKS. So we'll talk a little bit about that. That's our managed Kubernetes service. And there's my Docker image repository. So why containers? What does that really have to do with cloud, open source, Linux, everything? Remember the problems we identified in the beginning? It addresses them directly. It now enables this write once, run anywhere ability for your applications. It really kind of enables and empowers microservice architecture. For the operations side, it's portable. You now can have standardized development, QA, prod environments. Everything that we talked about as a pain point is directly addressed. So now what is a container? Container's not a real thing. Shock people sometimes when I say that. It's simply an application delivery mechanism with process isolation. And it's based on several key Linux kernel features. So you might hear namespaces. You'll see that in a demo at the end. I have everything deployed out into individual namespaces. It's also a best practice. But namespaces is what a process can see. So that's things like your PIDs or your mounts, your network, your C groups, your users. And C groups is what a process can actually use. So most importantly, and things you'll probably really end up defining, is memory and CPU. So as I go out and I deploy that Jenkins build server, I can set resource requests and limits. So if it doesn't have that particular amount of memory or CPU, it won't try to do the deployment because it doesn't meet what it's requesting. That's also another best practice. What's Docker? I'm guessing probably most people in the room know what Docker is, but it's an open source container runtime, Mac, Linux, and Windows support. It's a command line tool. We use pretty much the Docker file format for all of that. And the Docker image format uses a layered file system. This allows us to make sure our images are ideally nice and small, another security best practice, but then also streamlined. So when I make that one change to my Croc Hunter image, and if I can't really zoom in because it's PowerPoint, but if you look closely, each one of those layers are layers actually for my Croc Hunter application. So everything's defined. If I make only one change, it's only going to change one part of that layer. How do containers differ from virtualization? We've talked about traditional and the old, and this is kind of newer. How does this really look in comparison? Two types of virtualization. You have one where, unplug and plug it back in again. Two types of virtualization. You have one where your hypervisor sits directly on top of your hardware. You have a second where your host operating system sits on top of your hardware, and the hypervisor sits on top of that. But in any kind of scenario, you're going to have virtual machines on top of that. Your virtual machine isn't going to need a guest operating system. It's going to need any of your application dependencies. And it's going to need your actual application, of course, as well. So that means if any of your application dependencies that's installed on top of the guest OS changes from maybe your dev to your QA to your prod, and all the dependencies kind of, for example, are the wrong version of Java, your application might have errors. But in containers, you have your host operating system. You have the Docker engine that sits on top of that. Any dependencies you need for your system can sit on top. But in a container, your container has both your application and your dependencies. So it's essentially an encapsulated runtime environment. Switch the slide. OK, I really didn't like that slide. Yeah, that's cool. So the advantages of using containers. Remember, we've talked about problems for developers and for IT. First off, it has fast iteration. So you're able to now iterate faster. You don't have to worry about IT suspending your innovation and your productivity. You can have agile delivery. It's immutable. It's portable. For IT, there's cost savings. I'm not having to spin up so many dedicated virtual machines for my different environments. I can have everything running in environments on one tiny container. Actually, my most recent blog post talked about how to make a Docker file with a private repo as part of your Docker file. And if you used Ubuntu as the base image, your image was 83 megabytes. If you used Alpine, your image was 8. So you have something that's now ridiculously small and portable. You have a more efficient deployment. And you even have things like elastic bursting, which is going from the public cloud into the private cloud or vice versa based on demand. Container orchestration now. We'll talk a little bit more about Kubernetes. Kubernetes, as I said, is an open source container orchestrator that automates deployment, scaling, and management of applications. Features include things that you might recognize from DevOps practices: automatic bin packing, self-healing, horizontal scaling, service discovery, load balancing, the ability to roll out and then roll backwards, secrets and configuration management, so I can keep secrets that have my Docker pull credentials stored in it, and they're secure. It was originally designed by Google. It was donated to the Cloud Native Foundation. It's based on a system that they used that was called Borg, and they use it to run billions of containers per week. There are over 2,300 contributors, including Microsoft. We have a dedicated team. So when we offer Kubernetes on Azure, it's not a Microsoft branch. It's 100% upstream. Who's using Kubernetes? Is it really ready for production? I don't know, a handful of small names maybe. So you have companies like Reddit, you have Zendesk, you have Twitter, Spotify, Shopify. Anyone remember a little fun game from a few years ago? Pokemon Go? Ticketmaster, Walmart, Concur. This is production ready, mainly because of the stability and the growth of the community. AKS, now we'll talk about our specific offering. It is your Kubernetes cluster, but we manage it. What that means is it's still 100% open source, it's still 100% upstream, but we take care of the control plane. And because we manage it and make sure that it's self-healing, we also don't charge you for it. So why AKS? First off, it's easy to use. It's the fastest path to Kubernetes on Azure. You can get up and running with 3 simple commands. And I like to say it's technically 2.5, and I'll show you why. You can do automated upgrades and patching. You can easily scale your cluster up and down. If I have 3 nodes and I need 10, and I need 50, and then I need 100, I can do so with 1 command. And it's a self-healing control plane, like I said, that we manage. So these are the 3 commands to get started. The first one will create your AKS deployment. The second one is the one that's optional. That's why I said there's technically 2.5. That just installs the CLI to communicate with your cluster. So if you already have the CLI, which is kubectl, installed, you don't need to run that command again. And then you run AZ AKS get credentials. And by the way, those commands are Azure CLI commands, which is also open source and cross-platform. So it's our command line tool to interact with everything in Azure. Then the following command would make sure that your authentication between your clusters activated. You see your 3 nodes. The next slide is just managing it. So you can now list and see all your clusters. You can upgrade your different versions with one command, like I said. So you can go from one Kubernetes version to another. Then the final command is the scale command. That's where I can scale out my deployment. I start off with 3 nodes by default, unless otherwise specified. And then I just use the agent count flag to go up to however many agents I need. Kubernetes without AKS, or in truth, Kubernetes without a managed service provider. Google offers it, Amazon offers it, I'm pretty sure Oracle, HP, every company is trying to get into it now. But when it's not managed, you're responsible for the control plane and the agent pool, which means you're responsible for the hardware upgrades, canonical upgrades, manually draining each node and then cordoning everything off and upgrading your agents and doing a ton of work that really is just costly as far as time. But when you have a managed provider, we take care of that complicated part in the control plane. So that's why I said that it's 100% upstream over here. We handle the control plane part, and you don't have to pay for it. So tools to make this entire experience more simple. Every tool you see up here is a Microsoft-owned, for lack of a better word, but they're open source, tool. We have public repos for all 4 of these. We're going to demo 2 of them because there's a lot of content, and I can only fit so much in 45 minutes. But the 2 really important ones are Draft and Helm. We talked about Helm earlier, but as I showed you those Helm charts and trying to make it maybe for your application, if you're new to Kubernetes and you're new to declarative statements and wanting to define the world as you see it, perhaps making a Helm chart is just another task that you don't want to do. I don't blame you. That's where Draft comes in. So Helm, like I said, is a package manager. You can manage your complexity. You can easily update. You have simple sharing. So I can also package my Helm charts up as tarballs, put them in private Helm repositories, and then have that also as part of my source control attached to my build repos. I can also do rollbacks. So if I'm deploying out different services, different deployments, different pods, different databases, ingresses, everything, and I want to roll back to the previous release, rather than having to focus on X amount of kubectl commands to manage it from a Kubernetes instance, I can use Helm rollback and name the release, and I'm done. It'll take care of everything else. So this is another visualization of how everything kind of fits into one nice little box. But Draft simplifies this, because Draft allows you to use 2 simple commands, and you can essentially start hacking on your container applications. It'll create your charts for you. It'll create your Docker file for you. So if you have, let's say, a Python application, I choose that because that's what we're going to do in the demo. If you have a Python application and you just want to make a simple whatever your code change is, but you also want to commit it into your source repository that your DevOps team's working on, and Ops is using Kubernetes, and they need things like ingresses and networking and services and all this stuff that you don't focus on as a dev, you can all work in the same repo and have these files created for you. It does that using language packs. It's able to detect what language your code is written in, and then it uses packs to generate those files for you, based on the best practices of whatever that language is. So now we'll see a live demo of that. Switch over here. Hopefully the screen will like me enough to let me show you this. So I'm going to switch over to my terminal. By the way, you'll notice that now I have a watch command obviously running. So now that the deployment finished, it killed that container on its own. I don't even have to worry about going and deleting resources that stood up. It was because the way that file spun up the deployment, spun it up as a job. So it literally does what it's supposed to do, and then it goes away. So I'm going to zoom out here. I'm going to go over onto the right side of my screen. I'll kind of zoom in a little so you guys can see. I'm going to switch to my local development, which I've conveniently named Bad Wi-Fi. It's also my hack for when there's bad Wi-Fi at conferences. So now I've switched to my local instance. I'm not connected to the cloud or anything. I'm just going to hack as a developer. I'm going to cd into my example Python directory. I also have a Go directory, but we already know Helm works with Go because that was Croc Hunter. I'm going to open this up in code, and I might have to zoom out just a little bit because I want you to see, as soon as I get my mouse back, and we'll make this bigger just a little bit, and we're going to change this real quick. I'll make it say Jenkins World in a second. But first off, you'll notice I have the world's simplest application. Some might say the best, right? Most common, hello world. Python application with a requirements file. How do I get draft stuff in here? I'll switch back over to my terminal, scroll over here. I'm going to do a draft create command. Remember, I said 2 commands will do everything I need it to do. It automatically detected Python, says I'm ready to sail. What did that do? Well, zoom out here. I can see right over here with that 1 command, it now put my Docker file in there. It put my charts directory in there, including everything with predefined values, my templates. I can see my deployments. If I wanted to use ingresses, my service, everything was created from that 1 command. So like I said, 2 commands. So now I'm going to do a draft up. I'll hit enter. That built my Docker file right now, and it's releasing it into my local environment that I set up on my system. There's no cloud. There's no separate repositories externally. There's none of that. So now my application's up and running. Who believes me? Let's see. So I'm going to do a draft connect command right now. I'm going to let that Python application fire up. You can see that it's already listening. I'm going to copy this local host and IP address. I'll go over to the left side of my screen. I'll type in curl, and I'll hit paste. And I can zoom in. There's my application working right there. If I scroll down over here, I can see the GET request right there. So I'll cancel this, go back over into VS Code, close the service YAML, and now I'll change this to Jenkins World, hit save, back over to iTerm, do draft up 1 more time, because it's going to rebuild the Docker image and re-release it with my code change. It's already done. Now I do draft connect. I'll go ahead and grab this local host, curl, paste, live change right there. Just 2 commands. Now, I also mentioned, I'm going to clear this. We're going to clear the screen. I'm going to clear the screen completely, and then we'll clear over here. I'm going to change back to my Kubernetes cluster. So I also mentioned how you can deploy out a Jenkins build server with that 1 big file. And if we go back over and take a look at it, close this particular view of code. Let's take a look at what our Jenkins values file is, which is the file that I use, or the values. It's the knobs and dials for your Helm chart. If we zoom in, you can see everything I'm defining. And this is, we're not going to necessarily be able to look at it live, but I want you to see what it looks at. It takes about 5 minutes to deploy. But that's my host name, which was the same host name I was using for the demo. It's installing all these plugins for me, including Blue Ocean, which is one of the things you saw. I have all my script approvals set in there. I have an ingress routed up. And another best practice is I have role-based access control enabled on my cluster. All of that is defined by 1 file. And we have what's called Helm chart repositories that are publicly managed by not only our Helm team at Microsoft, but the Helm community, the open source community as a whole. So there's a ton of different charts. You can go to hub.kubeapps.com, which again is in the link you'll see at the end, or you can go to the GitHub repo, and you can see all these different charts. If you want to make a change or something to improve it, you can submit a pull request. I just did one to the MariaDB a few weeks ago, and the community is really great and super supportive. So we can see that I have a Jenkins Helm chart right there. That's in a stable repository. I can see that right over here. I'm looking at the, zoom in, I'm in the stable repo of GitHub. So all I have to do is use that file with that repo. I don't have to have the chart directory or anything locally on my system. So to prove that, go back over to my terminal, and I'm just going to do a Helm upgrade command. And if we zoom in and see what this says, I'm going to Helm upgrade, so I'm going to make sure this deployment can be upgraded in the future if I want it to. I'm going to use the install flag to where if it doesn't exist, don't just try to upgrade it, install it. The Jenkins demo live before install is the name of my release. I put it in its own namespace, which is its own little box. I specify my file and the stable release. That's it. And I hit enter. 1 command, and as soon as this releases, it says it doesn't release, so it's going to install it now. you'll see everything that my file just went out and talked to the stable Jenkins instance and is ultimately going to create. It's going to create my deployment, my services, my, let me zoom out here real quick. We'll kill this command up here. And then I'll clear that one window. So if I start scrolling and zoom in just a little so you guys can still see, I have a persistent volume claim it created, which is so my data can persist and it's not just a stateless container. It created a secret. It created my pod. It created my services. It created my cluster role binding, which was for my RBAC. It created my service account it needed for my RBAC. It handled my deployment. It set up my config map. It set up my ingress information, everything. So I also have a cert manager that's listening on my cluster. So every time I deploy out a new deployment of anything with an ingress defined, it'll go out and create an SSL certificate for my deployment so I don't even have to. And if you go take a look, it does that through Let's Encrypt and, again, a cert manager that's a Helm chart. But if you look at my Jenkins instance right here, which I can't even make that even any bigger, but you can see that it says connection secure, and the certificate is a valid certificate from Let's Encrypt. All of that's handled from these open source tools. So I'm going to close out of this. We'll zoom out. We'll go back and wrap up here. So best practices when using Kubernetes or using some of these open source tools is pretty much one of them is to use them. That's why I have Helm charts as one of them. But build small containers. Utilize the resources and options that you have available. Remember your application architecture. So use namespaces like I demoed. Use the Helm charts. If you start getting good at Helm charts and you want to, like I say, make a change, go submit a pull request. Get involved with our community. You can also go to opensource.microsoft.com. We have other resources. Utilize RBAC. Utilize role-based access control. These features were introduced by the community for a reason. Remember to implement health checks, so you can also check the health of your application. You'll see that in standard Helm charts as you start diving into it. Set requests and limits, as I mentioned earlier, with your CPU and memory usage. And be mindful of the services that you have. You can always map to external services, and don't always rely on load balancers. So you can set up a load balancer in Kubernetes. There's 3 different service types: node port, cluster IP, and load balancer. But then you're going to have individual IP addresses for all these individual services. The way that I do every deployment is I have one deployment, that's my Nginx ingress controller, or Azure also supports HTTP routing. There's another blog post you can go check out. But you can use both of those to essentially handle the routing for all of your applications, even if they're in different namespaces or whatever. And using that ingress is what's going to also help you with your cert managers. And like I said, the cert manager, the charts, everything, all open source and all things that we actually as a team focus on at Microsoft. Helm was originally started by a company called Deis at a company hackathon project about 4 years ago. And we acquired Deis a little over a year ago. We have a dedicated team where their only job is to focus on AKS, Helm, Draft, Brigade, Kashti. Follow all of the handles, get involved. We want to be participating with the community. Finally, thank you very much. Thank you for bearing with me with the flickering. For all of the resources and everything that I showed you in this demo, you can go to aka.ms/DevOps/Jenkins World 2018. Remember, you can find me online at JLDean, no relation to James Dean. You can also email me, jessica.dean@microsoft.com. But to be honest, I'm probably a lot more responsive on Twitter. It pings me, it shows up just as a text would on my phone. So yeah, if you have any questions, I guess I have about 5 minutes, so I'm more than happy to take a few questions now or come connect with me online or after. Thank you very much. Any questions in the room?
Are there any tools to help with RBAC management? Like, say, for example, you have a cluster, a bunch of devs, you want to create some sort of level of isolation, and you have got other crap running around there too. So, other than crew control, having to manually write, the bindings, is there anything to help with that layer?
So that's one of the things that I showed you in my demo for the Jenkins, is as part of each deployment, I attach RBAC to that deployment, and I can define my, I'll show you the link right here. So if you take a look, I'm actually defining the service account, I'm creating the reference, I'm creating the link as part of the chart. So then it actually gets saved as source control, version control. So I don't have to link it to a necessary developer or person, I'm linking it to a project and to an application. Because when you link any kind of authentication, whether it's something that's Active Directory from old Microsoft days, or now into more of an orchestrator perspective with abstraction, anytime you link it to a person, that person is replaceable. If they leave and they're the ones that you created the role binding for, what do? Link it to your service, link it to your application, put it in your version control and your source control. That was one of the other things on the most recent blog post I talked about, on how when you, so for those, I wasn't planning on talking about it, but if you are also familiar, we have our own CI/CD tool called Azure DevOps. And there's now free parallel builds for open source projects at Microsoft. But in order to authenticate to the private repos, which we give you an unlimited amount, you can either use a PAT, a personal access token, or an SSH key. And the reason why I wrote the blog post is somebody said, for this exact reason, how do I manage all these authentications when they're linked to various people and various developers? I have this PAT, and now that's part of my Docker file that I need to pull this code in and clone it, and it's linked over to so-and-so who left the company 6 months ago. Don't. Use the services that you have. You implement it in your Helm charts, or use SSH keys so that that way you can monitor and control everything as part of version control and source control more. Somebody else in the back. Sorry. Oh, yep, Helm 3, Chart Museum. I'm coming to you. This is my exercise for the day. I told you I love exercise. Whee! There we go.
Thank you. I'm just curious what the latest is for Helm 3. Any launch updates or?
So I don't have any launch updates. They don't tell me anything, or at least anything I can repeat. I can say that you can go, so we're also on Slack. So any of the Helm groups, Helm teams, Deis teams, we have a community for all of that. You can hang out in our Slack channel, and we'll also ping when there's new beta releases of certain things available. So half the time, I don't even know that something happened until I go into Slack, and I'm like, oh, there's an update that every other member of the community just saw too. So I tend to find out things when everyone else does. But Helm 3 is supposed to make a lot of changes. One in particular that was already public knowledge is we're removing tiller. So if people don't know how Helm actually works, I had my Helm client, which is local on my system. And so I can do a Helm init and get all my linkage over to my Kubernetes cluster. But it uses gRPC calls to communicate to my cluster, and there's a service called Tiller that's living in it. And essentially, I have the Helm client locally, Tiller's up here in my cluster, and it's communicating to all the Kubernetes APIs. It's an ineffective way of actually handling distribution, especially from growth and from a scaling perspective. So the idea, and Draft used to work the same way, by the way. I think back in Draft 2.8, we also used to have a Draft D, which was a daemon that used to live in the cluster. But it has to send all these requests, and then that person has to go give the requests. So in Helm 3, we're removing Tiller, and it'll just be a client-only system. Who else wants to make me run? Any other questions? I'll take one more. Oh, yes.
Sophisticated is Draft in, would it detect Python 2 versus Python 3? Or?
I don't believe that the versioning of Python matters, because it's still going to create a Docker file that's, in your Docker file, you might have to granulate it down, but as far as creating the Helm charts that's based on the best practices, it's not going to necessarily matter. You might have to, in your Docker file, the simple Docker file that we create, you can hold on to the microphone real quick. Can go back over and show you. Let me zoom out. So, this is really just going to build my application. It's just framework. It's just a skeleton. It's not necessarily writing everything I'm going to do. It gives me a starting point. Obviously, if I'm dependent on 2.7 versus 3, then I'm going to need to change that particular Docker image. As you start getting into also doing your own production real-time, I would recommend probably not using public images and have your own images that's baked in with what you need, or utilize multi-stage builds with whatever version. But this gives you the starting skeleton that then you can use. But since this is just the Docker file that it's literally going to build on, the Helm charts as a whole, if I go back over to the values, that's not going to matter with anything with Python. It's just saying if the image exists, pull policies, what type of service do I want to create, what kind of deployment. All of the Helm chart is going to reference whatever I define in the Docker file. So as I make sure that my Docker file is 100% for my application, my environment, and my corporate policies, Helm chart's just going to take that and run with it. But there shouldn't necessarily be a, I guess, reliability standpoint as far as if it can detect the different versions. You can also go, so I believe our handle for GitHub is create draft. Let's see. No, I think it's Azure Draft. Yep. So you can also go to Azure Draft. It is still new, right? It's still in its infancy. But if we scroll down here, you can see a list of all the packs, and you can see all the different languages that it supports. And if you want to learn even more about different versions, like especially like with Gradle or Maven or Ruby or all these things, you can drill down even further. That's one of the benefits of having all our code open source online, contributing to the community, is everything's there and available for you to not only see, but then help make better. It's the only way we're going to get better is if we work together. All right, I will come take the microphone back so you don't just have to have it sitting there. And thank you very much, everyone.
Thank you.
You're welcome.